So hello all. So in this video we'll be discussing about the real gas derivation from ideal gas. You can just see the video, so I'll be writing and you can just note it down. So real gas approach the ideal gas behavior for low pressure and high temperature. The same point is repeating. And coming to the next ideal gas equation, PV is equal to mu RT. For 1 mole it is mu is equal to 1, PV is equal to RT, and PV by RT is equal to constant. Okay, so we already learned this equation. PV is equal to mu RT, and P which is pressure, V which is volume, and T which is temperature. For 1 mole we already learned that mu is equal to 1. Okay, so PV is equal to RT, so PV by RT will be equal to constant. So the graph should be a straight line parallel to x-axis for ideal gas. So these kind of questions will be definitely asked in the examination, that what the graph will be a straight line parallel to x-axis for ideal gas. So this means that it has constant value at all temperature and all pressure. So but in case of real gas graph approach, ideal gas behavior of a temperature and low pressure. At high temperature and low pressure, molecules are far apart, correct? When the temperature is increased, the molecules will move randomly far from each other. As a result, molecular interaction decreases. The gas behaves as ideal gas. The ideal behavior comes into picture when the molecule present inside the gas do not interact with each other. Okay, so real gas approach, ideal gas behavior, low pressure and high temperature. You can just see the graph that the real gas approach, ideal gas behavior at low temperature and pressure, it would look like a straight line. Okay, you would have noticed that it is completely a straight line. Okay, so deduction of Boyle's law and Charle's law from perfect gas equation. So according to Boyle's law, what we know that Boyle's law states that at constant temperature, pressure is inversely proportional to volume, right? So before we already know the equation, like PV is equal to mu RT. So in that case we have to consider temperature and number of moles constant. So therefore PV will be equal to constant. And according to Boyle's law, at a constant temperature, the pressure is inversely proportional to volume. So these things are already discussed by us. And coming to the Charle's law, which will be constant, pressure will be constant, and the temperature will be directly proportional to volume, right? Temperature will be directly proportional to volume. So from here also we will be taking the perfect gas equation, that is PV is equal to mu RT, where pressure is constant. So the equation will be V by T is equal to mu R by P. So mu R by P is equal to constant. Okay, so V by T is equal to constant. So we can conclude that V is directly proportional to temperature. So according to Charle's law, for a fixed temperature, the volume of the gas is directly proportional to absolute temperature. So what we can conclude from these two laws is that ideal gas satisfies the Boyle's law and Charle's law as well. So you can just understand that this ideal gas will obey the two laws. Okay, that is Boyle's law and Charle's law. So what is meant by Boyle's law? At constant temperature, pressure is inversely proportional to volume. What is meant by the word inversely proportional? If one quantity rises, other quantity comes down. If one quantity comes down, other quantity is going up. Okay, so that is the meaning of inversely proportional. And for Charle's law, if the pressure is constant, the volume is directly proportional to temperature, which means if the volume is more, the temperature given should also be more. If the volume is less, the temperature given should also be less. Okay, so both are directly proportional to each other. So in this video we just discussed about those ideal gas deviations and deviation from ideal gas, and we also discussed about Boyle's and Charles law. Okay, thank you.